Hello, I'm Brian Horizon, and this video is how to turn a twisted peppermill, like one of these examples you see up front. Here you can see the internals of the peppermill. We're able to put the peppercorns in a nice ceramic grinder on the bottom. These internal parts are available at Penn State Industries, and I'll give you some references during the video. We're going to turn this particular twisted peppermill, and you'll see the steps as we go through this video and slides. But I'm assuming you have some knowledge of how to turn a twist, like you see on this basic shape. If not, there's some references on this. You can go to my website and I'll show you in steps how to do this, but I recommend you do some practicing on some blanks. This is a piece of poplar. Before you start turning your peppermill out of a good piece of wood, feel comfortable on the practice wood. So let's get started, and I'll see you at the end of the video. Here's some references to help you get started. You can go to my website on the links page, and you can see an off-center turning overview to help you learn how to do the three-sided off-center turning, or a PDF of this full presentation. The parts you'll need to do this project are a turning blank of a piece of your favorite wood, about 9 to 10 inches long and 3 inches on a side, and the internal mechanism that you can get from Penn State Industries. Let's get started with the turning. I've trimmed the edges of this blank, and now I'm going to turn it into a cylinder using a roughing gouge. Engage the tool on the tool wrist and start slowly turning away the material until you have a cylinder. You can notice the sound changes a little bit as it gets more cylindrical. You can hold your tool on top and check to make sure it's a smooth surface. Now I'm going to use my badan to turn a tenon on the end, about a ½ inch in. This tenon will allow us to grab the pieces when we start to finish the turnings, and also give us a gauge for estimating equal sides on the three-sided turning. Now we're going to mark some lines to do our internal tenon, and also to give us some reference lines to line up the pieces once we've cut the tenon and parted the piece. We're just about ready to start cutting the holes and boring out the center. If you haven't bought Forstner bits for this, and if you're going to make more than one, I recommend buying a set of Forstner bits. Now we're going to cut the internal tenon, but I'm going to size it to this Forstner bit that's 1½ inches, slightly larger than the internal main hole. Checking my calipers for sizing. Using my badan, or you could use a parting tool, we're going to turn the tenon down to 1½ inches. We want clean upper and lower edges because this is where the parts are going to fit back together when we're done. We can use the calipers to measure the internal tenon to make sure we've got it to the right diameter. The next thing we've got to do is part the two pieces. Here we want to keep the tenon with the upper piece. I'm using a parting tool to get the cut started. I don't part all the way through with a parting tool. I stop the parting, and then I use a small saw to complete the separation of the parts. Now we've got two separate pieces, and it's time to start cutting some more holes with our Forstner bits. We want to cut a hole into the upper piece that's about 1/8 inch longer than our tenon that we just made. You'll see why in a subsequent step, why we need that additional depth of tenon cut. Now we mount the longer lower piece on our chuck, making sure we have it on center and rotating it to ensure center. We don't want this thing to be off center or things won't line up. We then use the Forstner bit to turn a hole to the desired depth and check the fit of the upper piece, turning out a little more material as needed so we get a secure, snug fit of the upper and lower pieces. We need to immobilize the upper and lower parts, otherwise they'll twist and rotate and mess up our gentle curves. So we do this with small pins made from finishing nails that stick out about 1/4 inch or about 1/8 of an inch more than the distance between the two parts. With the pins inserted, put the parts together using the alignment marks and the tailstock to push the two pieces together. We're just about ready to start turning our twist, but we've got to mark our offset points here 120 degrees apart. And I've drawn a line down to the base to show where I want the twist to be. We'll mark 1 to 1, 2 to 2, and 3 to 3 to start turning the twist. With the blank mounted on the lathe between our offset points 1 to 1, you can see that there's clearance checks we need to do between the tool rest. It really doesn't look this bad. I think it's the film making it look a little wobbly, but we're going to use our roughing gouge to gently start turning. The ends are where you can take the biggest bite if you're not careful, but just gentle turning, actually turning a curve in the center, allows us to get the desired shape. Now remember the tenons? We're going to use those tenons to show us whether we've got the required or the desired amount of depth on each side. There's the tenon, and we're just starting to get that side done. We'll keep turning to get the required level of cut and making sure each side is equal, and also starting to get a nice defined edge between the surfaces. Here again you can see the tenons are a little deeper, and we've got that nice clean edge between the surfaces. With the lathe turned off, we can actually do some finish sanding on each of the sides, taking care not to sand off those nice sharp edges we worked so hard to achieve. The twisted turning is done. Now we need to take the pieces apart, remove the pins, and get ready to start boring out the internals so we can put the mechanism into the Peppermill. With the base mounted on the chuck, I'm going to bore the center hole halfway in to the twisted lower piece. Then I'm going to flip the piece around and get ready to start boring from the other end. Here I want to size the depth of the cut to add a little bit so that then I can part that tenon off once I've got the hole cut. I've added about 1/4 inch to compensate for the tenon. So I'm boring into the other end now. I've flipped it around, and holding the pieces is always a challenge, but if you've got the chucks, you can figure it out. Here's a hint: use internal jaws to hold the other end of the piece. With the Forstner bit in place, but far enough in so the shaft is there, I'm going to part off that tenon, and then clean it out and use a flat piece of sandpaper on a piece of plywood and flat sand the base. I'll complete boring the holes in the base, always using the largest Forstner first, and then mount the upper piece on the chuck and bore the small hole for the upper fitting. Then I'll flip the top piece around, put it back in the chuck, and I'm going to start turning away the upper portion to get rid of the hole marks and to make a nice rounded shape. Here I'm using a Hunter detail tool, but you can use a detail gouge just as well. Then I shift to my negative rake scraper here to make a nice smooth contoured upper surface. With all the holes cut, we're ready to start installing the interior pieces. Only a few minor steps left. Because these parts were made for metric sizing, we have to trim off the little ridges. There's 6 of them. Use a sharp knife and trim these off so it'll fit nicely into the 1.5 inch hole. Then when it's inserted and pushed all the way in, we're going to trim the upper shaft off. It's aluminum, so you can cut this easily. I've got this about 1/2 inch above the upper rim. When I put it together, rather than gluing it, I use 3 stainless steel screws. These are number 6 screws, 1/2 inch long, to hold it in place. Dry fit your parts, apply your final finish, and there you have it, a twisted Peppermill, here made in honey locust. That's it. I hope you enjoyed the video on how to turn a twisted Peppermill. If you've got any questions, I've got an email link at the end of the video along with some good references. Enjoy, and make sure you pay attention to your tool positions and you keep your tools sharp and you wear the proper clothing. Thank you.